This is Hastings Math Videos. Thank you for joining us. Today, I'm doing some videos on the Edexcel P3. This video is question 8, which deals with integration, specifically with trigonometry integration. If you'd just like to jump to sort of seeing a more extended answer, then I have that already written down here for you. So you can just look through this. I just want to check that that's everything for question 8. Sometimes I have more. No. Okay. So it's just this little bit of working. You can pause the video and take a look at that. But if you want some explanations, then I'm going to go through it in more detail. Okay. So question 8 deals with integrating trig stuff. Let's see. So they give you a bracket with cos minus sine. Okay, when I see this, first I think of the r cos theta thing, but I don't think it's that because there's a square here. So first thing we have to deal with is to expand these brackets. So we don't want that square. Okay. So bringing down your integrating sign every time, just so that you have it. There's 2 of these brackets, and it's the difference between 2 squares. If you have a squared minus b squared, that's the difference between, excuse me, what am I doing? It's not the difference between 2 squares. No, it's exactly not that. It's 2 of exactly the same brackets. So if we had a minus b squared, that's equal to 2 of exactly the same brackets. Okay. So we're dealing with this. We're not dealing with the difference between 2 squares. Put in my x's. Goodness me, what's going on? Cos x minus sine x. And this is with respect to x. Okay. So a little bit of algebra. You can do it the quick way, or we can do it the long way. The first term squared, so we could have just squared the 2, squared the cos, or we could say this times this. Either way works. So it's 4 cos squared x. The middle term, it's this times this and this times this plus together. Alternatively, you just take the first one plus the second one and you times that by 2. Okay. So those are all the options that we have available to us. So we get 2 cos, excuse me, it's not plus, it's times. So 2 cos x times negative sine x times by 2. 2 cos x times negative sine x times by 2, which is a negative 4 sine x cos x. Okay. Final, you could just square this. So it'll be positive sine squared x, or you could look at it as timesing sine x by sine x. Okay, so those are your 2 options, depending on how you set it up for yourself. Okay. So we have positive sine squared x. And don't forget, this is all with respect to x. Okay. So it's looking a little better. When I look at this, I see, well, so far we have nothing we can work with. We have to change all of this into something we can work with. First thing I usually notice when I look at these equations is I'm quite good at noticing that this looks a little bit like sine 2x, but not quite right. So what do I mean by that? I mean that the double angle identity of sine 2a is equal to 2 sine x cos x. There's only one option, so I always go for this one first. So that's almost there. So if I rewrote this as 2 times 2 sine x cos x, then we're already there. So if I do that straight away, my next step, I'm just going to set it up like this. The middle term will be just negative 2 sine 2x. Okay, so you can straight away if I track that with color, I exchanged this whole thing for this, and then that equals this, which is this. Okay, there's -2 times that. If you can't track that, just rewind the video and take a look again. Okay, so I've stuck with this thing. And these ones are less obvious. They're not like they don't jump out at me quite as much. If you had a lot of practice, then it starts to jump out. So the way that I see it is we have our options. So when we have cos of 2 angles, sorry, the double angle of cos 2 of some sort of angle has 3 options. Okay. I wanted an option with cosine, so we'll start with that one. So we're starting with this one. So we want the option with cos squared x. Cos squared x is, this one has cos squared x in, so I could use this one. And let's first do that and then move on to the next question. So the way I'm currently tracking this is for teaching is that I'm trying to make this whole thing look like this. Okay. So it needs a little bit of rearranging. Our cos 2a plus 1 over 2 will equal cos 2a. So this part is, you can do it in your head or you can write it down depending on how much practice you've had. That's the bit that's being assumed. So wherever we saw the cos 2a, we can just replace it. So we have 4 of this whole thing. I'm just going to split this up a little bit. So if I were to split this up a little bit, it would be a half cos 2a plus a half. So I just split the denominator. Okay. Goes on that, it goes on that. So just to make it look a bit more like the previous work that I did, not really at this stage for any other reason, except that that's how I did it before. So we've dealt with the cos, put it in a double angle instead of the square. Now we're doing, we've dealt with the middle one, and we just have to do the last sign. Okay. So if I track that through with color, we could have, we've got to find some sort of double angle identity. Before I do that, let me just bring down the amounts here. We're getting a little bit messy. So -2 sine 2x. Okay, plus sine squared x dx. Good. So this is what it looks like so far. And I am tracking this one down. So this green one is the one we want. So if you know your double angle identities, then, oopsie, cos 2a, not sine, will be equal to, and this time I'm going to use the one that has sine squared a in. So this one. Okay. So we want to make this look like this. Let's just rearrange it this time before we start. So cos 2a minus 1 divided by -2 this time is going to be equal to sine squared a, which is what we want. That's what we want it to look like. We're close, but this time before I continue, I just want to split this up. So it'll be -1/2 cos 2a. Negative and a negative is positive, +1/2. Okay. So this is what we're replacing. This whole thing is exactly the same as that. Okay. So nearly there, nearly there. Let me write it in. Yeah. So we're integrating. I just want to times that 4 in. So keep the bracket going. 4 divided by, oh gosh. No, why? There we go. 4 divided by 2 is 2. So 2 cos 2x. That was just timesing it in there. And then we're timesing it into the half plus 1/4. Minus 2 sine 2x's plus this whole thing. So if we're plussing this whole thing, it'll be immediately negative. There's no sort of a value or anything to worry about. So we just have -1/2 cos 2x plus 1/2. Okay. So this is our integration. I think I can tidy it up a little bit more even because I see some terms that are like terms. So we have constant terms we could deal with, and then we have two lots of cos 2a we can deal with. So we maybe clean it up a little bit more. So we're actually integrating 2 minus a half is 3/4. 1.5. No, what am I doing? 2 minus a half is 3/2. Okay. 3, yeah, 3. 1.5 is 3/2. Perfect. 1/4 plus a half. Well, let me do it a little bit more mathy and bring this down. I just brought that down. So a little bit more mathy is you would find a common denominator of 4. So this 1/2 would become 2/4. And so it becomes 3/4. Okay. Just want to check that I haven't done something different. So I have here a 5/2. And so I'm just wondering if I missed something in my working when I'm teaching. I do tend to, it seems there was a 2 there. So I had the 4 times by half and I got 1/4 for some reason. Goodness me. That should have been, that's my error. Quickly just clean up my error. That would have been 4/2, which does not at all equal 1/4. Oopsie. So no, that's 2. And then our constant is changed. Okay. So our constant is 5/2. Yes. Now we can finally integrate this funny looking thing. So the integration part, probably the easier part in these sorts of questions. It's just knowing what can be integrated and what can't be integrated. So now we can just change cos and sine to sine and cos. Just make sure that you notice the changes in sine. So let me see when cos changes to sine. Oh, oopsie. I just paused the video for a second there just to go grab this. So this is in the P3 textbook. I just didn't want to, make a silly error long teaching day. So these are the integrations that you should know off by heart for your exam. So we're just using these two. Okay. So we're looking at cos and sine, and when you integrate it, cos goes to sine, but positive, and sine goes to negative cos. So just to look at that. And just in addition to this, we have a value of 2, which just uses what I call the chain rule. So what do I mean by that? If we had cos 2x, it would be exactly the same. It would become, going from this one, it would be sine 2x times by 2 plus c. Excuse me, we're integrating. So you divide. Okay. So if you take this rule and we apply it, I just want to talk a little bit about, so we had, if you look at this list, we had none of these options in our original equation, which is why we rearranged it to look like. So why did I change to cos 2x and to sine 2x? It's just because in order to integrate it, I want one of these options in order to integrate it. That no other reason. You want to make it look like something that integrates easily. So let's do these one by one. So 3/2 cos 2x integrates to 3/2. So using this one, cos changes to sine. So sine 2x, but remember that we're integrating, so it's divided by 2. You divide by this value, which is the first derivative of the function inside the function. So the first derivative of 2x is 2. Then we have sine, but the sign is going to change. So we're going this way. Then the sign changes. So it'll be 2 cosine 2x divided by 2. But the sign has changed. So I make that into a plus. Take away the bracket. Okay. Plus 5 over 2. X plus 1, because it was an x0. So now it's going to be x1. Divided by 1. So that doesn't change anything. It's just x. Okay. Finally integrated our question, and all that's left to do is make it look pretty. Just grab the answer there. So when you make it look pretty, it ends up looking like that. So 2 times 2 is 4. Oopsie. 3 over 4 sine 2x. The 2's cancel out, so it's just cos 2x. And then we have 5 over 2x plus c. Don't forget the plus c, hallmark for plus c. Okay, good. So this was question 8.